Open source AI must win. A one-page manifesto dropped yesterday and spread fast. Nice words. But the real question is a different one. That open model, will it actually run on your machine? Who wrote this and why? How much hardware each model tier really costs? And what the people who've actually run them have to say. We'll go all the way down to a real spec sheet. The claim is simple. If you only ever rent intelligence from a few closed companies, you lose the freedom to run it yourself. But this wasn't written by some idealist. The author runs the largest community of people running local models and builds his own GPU clusters as a systems engineer. In other words, it's a cry from someone who runs models himself every single day. So take it not as a slogan, but as a spec sheet. The manifesto comes down to 2 lines. First, if you only rent intelligence, what you lose isn't software freedom, it's the freedom to run it yourself. Second, a warning. When a few control the models, infrastructure turns into a monthly subscription for cognition. So I put it in a table. Everything here assumes 4-bit quantization. Start with the light end. The lightweight 7 to 9 B tier runs in about 8 gigs, so it works on a 12 gig graphics card or an entry-level Mac. The practical 27 to 32 B tier sits around 20 gigs, and one 24 gig card is a perfect fit. Now the heavy end. The high-performance 70 B tier crosses 40 gigs, so you need 2 graphics cards or a Mac with lots of unified memory. The Frontier, 235B and up, runs into the hundreds of gigs, so it's basically workstation or data center territory. In reality, the right answer is almost always the middle. Put a 27B model on a single 24 gig card, and real work like coding and summarizing runs just fine. That's exactly the spot the community runs the most. Take the table at face value, and you walk into traps. First, 4-bit isn't the same as the original. Memory drops to a quarter, but for coding and reasoning, 6-bit or higher is recommended. Second, leave memory headroom. Longer context eats more cache, so add 20 to 30% on top of the table numbers. Third, just swapping the runtime can make the same model up to 30% faster. DeepPulse Deep Dive. My advice is short. Don't try to run a full Frontier model at home. Instead, pick the one tier from the table your hardware can handle. One 24 gig card means the 27 to 32 B tier. A Mac with big unified memory means the 70 B tier. And don't bake the model into your code, pull it out into config. Then on the day the cloud goes down, you swap in a local model by changing a single config line. Plenty of people already work exactly that way. The reports from people who've actually run them fell into 4 groups. First, 27B is a real beast. Many run it on a single 24 gig card for real work. Second, fallback genuinely works. Because their automation isn't tied to one model, they switched from cloud to local with a single config line. Third, the open ecosystem is being pulled along by China. Fourth, the cautious take, weights alone aren't enough, and 4-bit isn't the original. To wrap up, this isn't something to end on the slogan that open wins. Pick one set of open models that fits your hardware tier and keep it plugged in with a single config line. In an age of renting, that's the most realistic move you can make to keep a hand on the switch. That was today's DeepPulse. Even in an age of renting, one set that fits your hardware tier can stay in your own hands.